Hello again. Thanks for joining us on a Q&A edition of Space Nuts. My name is Andrew Dunkley, and today Fred will be answering questions about the former planet known as Theia. Galaxy mergers have come up. We go back to Mars with a theory about Olympus Mons. And why only hydrogen? That is a question that comes from, I believe, a 5-year-old. We'll deal with all of that today on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And to solve all of those little riddles, we're joined again by Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. Very good to see you again.
Good to see you too. We've got a bit of weird noise on your line. I think it's probably just the internet being the internet, so hopefully that'll go away.
Okay.
In fact, it just did. So, yeah, there you go. Solved itself. It must have heard me whinging. All is well, I assume?
Yeah, we're doing fine, thank you. It's good to join you on the questions episode of, what's this called again? Oh, Space Nuts, that's right.
Space Idiots. Space Nuts, yes. Yeah. No, they're all good people. We might as well jump in straight away to our first question, and it comes from one of our regular contributors. It's Rusty.
G'day, Fred and Andrew. It's Rusty in Donnybrook. I've been listening to your latest episode where you look at the relationship between Theia and the Earth before the collision. And I just want to make sure I've got the story straight, so I'll put it in my own words. The Earth had a buddy named Theia who came a little too near. She hit with a splash, then made off with a dash. But there's no mooning for Theia around here. So what happened to Theia after the collision? The theories prior to this revelation said Theia had enough kinetic energy to leave the solar system altogether. But if the orbits were so close, that doesn't seem likely. So it seems to me there's 3 possibilities: that Theia fell into the sun, which would be another amazing feat to get that sort of precision after the collision. Theia picked up a little slingshot energy and moved out further and became Mars. And Mars is a Mars-sized object after all. And the third possibility I can think of is that it picked up an unlikely amount of kinetic energy and became Planet 9. So if it did become Planet 9, it would have a highly eccentric orbit because it's too far away for us to actually see at the moment. But would this orbit then at some stage bring it back to the inner solar system of its origin? That's it. Hope you guys are well. Cheers.
Thanks, Rusty. Hope you're well too over there in WA. What happened to Theia? He's come up with some interesting theories, quite a few ideas. I'm guessing they can't all be true.
I think that's right. There's actually a 4th possibility added to the 3 that Rusty has proposed. And I think that's the one that's usually accepted, and there's kind of evidence for that. The 4th possibility is that Theia basically was absorbed into the Earth. The remnants of Theia are actually in the Earth's mantle. And in fact, there's something called, and there are 2 of these, a large low shear velocity province in the Earth's lower mantle. And the hypothesis is that that is the remnants of Theia, so that we still see the evidence of that collision by anomalies, basically, in the Earth's mantle, which we investigate with seismology. That's how we know about what's going on in the mantle of the Earth. It's how we know about large, low shear velocity provinces. I'm kind of just using the words here because I'm not somebody who knows about the inside of the planet, other than the sketchiest outline of a core, a mantle, and a crust. But the mantle we know has significant structure, and in fact, Marnie and I have a good friend, Nick Petford, who is a volcanologist, and he's somebody who looks at these velocity structures in the mantle of the Earth, and the upwelling of material to form volcanoes and things like that. Next time we see Nick, I will ask him about these large-scale, low-velocity shear areas and their relationship to Theia. But I think that's the consensus, Rusty, that the impact basically resulted in an explosion which shed something like, I think one of the suggestions is about 70% of the mass of the moon may have come from Theia. I'm actually, I think that might, let's put it this way. Theia is responsible for 70 to 90% of the total mass of the moon under the classic giant impact scenario, where Theia is considerably smaller than a proto-Earth, which it would have been. The Earth was still kind of Earthish sized. Theia was Marsish sized, but the Earth would have probably grown a bit by absorbing the debris from Theia. Remember that the mass of the moon is about 1/80th of the mass of the Earth. Mm-hmm. So it's a significantly large body compared with the other moons in the solar system. But it's clearly smaller than, it's not Mars-sized. And so Rusty's right in that the remnants of Theia had to do something, but the current theory is that they were absorbed by the proto-Earth, and we can still see evidence for them.
Yeah. Okay. So, yeah, definitely not likely to be P9. That would be a very odd kind of occurrence, wouldn't it?
Yeah, well, yes. I think the kinematics don't work. You can't give it enough velocity, and you'd need a lot of velocity for it to fall back into the sun as well. Too much energy. That's quite an energetic process. Is getting rid of the orbital velocity of a body to make it fall into the sun. It's you need as much energy as you do to get it pushed out to the outer planet. So
yeah, didn't we talk about it once before and suggest that remnants of it just probably speared off into space, never to be seen again?
I'm sure there would have been an element of that. Yes, and that debris cloud that eventually formed the moon probably lost some of its material content, and there may even be stuff wandering around in the form of near-Earth asteroids now that are bits and pieces that are left over from that. But remember, this was within the first couple of 100 million years of the history of the solar system. So you're talking about things that happened a very long time ago.
Yeah, indeed. I'm wondering, Fred, why we've just got this sudden influx of people asking questions in poem. This is I'm blaming Martin for that. Martin Berman Gorvine. You started this, and now it's taking
I actually think I really liked Rusty's one there about Theia. I thought that was very nice.
Yeah, I don't know. I think he pushed it a bit on one of those rhymes. Yeah. Although there was a regular guest, and I'm sure you know who I'm talking about, Cole Wilson, who used to join us on the radio once a week to do bush poetry. Blew the shearer, and he often got asked to do shearing demonstrations, and he had to tell them, look, I'm not a shearer. I couldn't shear a sheep to save my life. It's just my show name. But he used to actually invent words to create rhymes. It was one of his wonderful traits, and I used to spend a lot of time with Cole. He's a terrific bloke. I think we've dealt with Rusty's theories, and they were all wrong.
Thanks, Rusty.
Thanks, Rusty. Great to hear from you. Let's take a break from the show to tell you about our sponsor, Incogni. Now, if you've been overwhelmed by a barrage of spam calls and emails and targeted ads, robocalls, it's probably because they can find you online very, very easily and just harvest your contact information. If you've ever felt like that, then the answer is Incogni. What happens is data brokers collect and sell your details, leading to an endless array of spam and other potential risks. And if you want to get rid of that, Incogni is the answer. It's your personal data removal assistant. It automatically sends removal requests to over 210 data brokers, ensuring your information is taken down. You can even watch the progress of it through an online dashboard. With weekly updates, you can track the cleansing of your digital footprint. Plus, there's a 30-day money-back guarantee, so it's risk-free. It's called Incogni. Take control of your online presence. Visit incogni.com/spacenuts. And here's the kicker: 60% off if you use the code word spacenuts. That's incogni.com/spacenuts. 60% off if you use the code word spacenuts. Enjoy a peaceful online existence without digital disturbance.
Listen, Tranquility Base here. The Eagle has landed.
Space Nuts.
Let's move on to our next question, and this one I've lost. Here it is. This comes from Lena. I am a new listener and not as hardcore a space nut as most of your audience. It's probably a good thing. But I saw an article today talking about merging spiral galaxies. If the universe is expanding, how does something as large as a galaxy move toward and merge with another galaxy? It seems they should be moving further away from each other. That comes from Melina in British Columbia in Canada. I think we've had questions of this ilk before, but it's always good to go over it again because there's a lot more going on in the universe than just, spreading out like school children playing, what's that game where you don't, I don't know what you call it. Something you throw a ball and try and hit someone in the head. Anyway, go on.
That's cricket, isn't it?
No, dodgeball. And there's a whole bunch of games like that, like Red Rover Crossover. Did you ever play that?
We
no, we used to have a lot of fun with that.
Anyway, look, Lena's question's a great one, and I guess the simplest answer here is that yes, galaxies are big, but they're tiny compared with the universe. And so the expansion of the universe is something that we look at on very large scales. You're looking out billions of light years and seeing this expansion. It's actually, with today's technology, it's one of the easiest observations that you can make, that the universe is expanding, discovered back in 1929 by Edwin Hubble. So if the universe is expanding, if space is getting bigger and naturally carrying things further and further apart, why are some galaxies coming towards each other? And it's because on the scale of a galaxy, the expansion of the universe is minuscule, and by far the dominant process is gravity. So galaxies, which yes are being carried gradually apart by the expansion of the universe, when you put them close together, their own gravity gives them a force that pulls them together that's much greater than the expansion. And we actually give that a name. We call this the peculiar velocities of galaxies, because it's a velocity peculiar to an individual galaxy. And the usual way that we describe it, and I think we've talked about this before on Space Nuts, is if you imagine a river flowing, which represents the kind of expansion of the universe, and then somebody in a boat is moving around on the river. They're being carried downstream by the river's movement, but they've got their own movement provided by the boat on the water. And it's a bit like that with galaxies. They're being carried along by the expansion of the universe, but a far bigger effect is the way gravity pulls them together. So that's what's pulling our galaxy and the Andromeda galaxy together. It's the gravitational force between them. And on the scale of the distance between Andromeda and our own galaxy, which is about 2.5 million light years, the expansion of the universe makes virtually no difference. You only start really noticing it when you get to much bigger scales.
Yeah, but there will come a point in time where all these galaxy mergers will will finish. They'll be done and dusted, and the universe will keep expanding, and eventually there'll just be darkness. There'll be nothing.
Yeah, if that's assuming dark
There
energy.
isn't a big crunch? Oh, right.
Yeah. I mean, dark energy, we're now just starting to see the first signs that maybe over the last few billion years it's decreased. So the acceleration of the universe, it's still accelerating. The expansion is still getting faster, but it's getting faster at a slower rate, if I put it that way. So the acceleration itself looks as though it's declining. And that's why some people are still talking about the big crunch or the Gunab Gib again. It's because if the acceleration eventually goes away and becomes a deceleration, then you're going to get a big crunch.
Yeah. It's, could go either way at this stage, the way they're talking. We have witnessed some galaxy mergers, haven't we? Doesn't our own galaxy actually contain a couple of other galaxies that have been sucked into our void?
Yeah, two quite big ones, actually. The things we call the Large and Small Magellanic Clouds. They are satellite galaxies of our own, and they're being stripped of their stars by our own galaxy, its gravitational pull, and will eventually be part of the halo of our own galaxy. But we also see examples in deep space of big galaxies actually merging. The most famous is the antenna galaxies, two galaxies which are merging and pulling off spiral arms off each other in quite a dramatic fashion.
Yeah, it all happens in slow motion, though, doesn't it? And when people think about galaxy mergers, they're thinking all this drama and collisions, but it generally doesn't turn out that way.
Well, you're talking about processes that take millions of years, and and in fact, galaxies, probably when they collide, you don't get stars actually colliding because there's so much space between the stars. But what you get is the effect of clouds of gas colliding, and that spawns new star formation. So you might get lots of hot young stars being born in a galaxy collision.
All right, here's my horrible attempt at poetry. It's more of a dance than a glance.
Oh, I like that.
Yeah.
Yeah, it is actually. That's exactly what it is. Yeah.
There we go. All right. Hope that answered your question, Lena. Thanks for sending it in, and thanks for listening to Space Nuts, which is what you're doing right now with Andrew Dunkley and Professor Fred Watson.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Space Nuts.
And our next question comes from Kevin, and he said, I've been listening with much learning and enjoyment to all the previous podcasts. I'm about halfway through them. So he's at around 200 and nearly 300, I imagine. So let's just wait for him to catch up. He says, your discussions of Mars and its lack of atmosphere made me wonder if perhaps what must have been an enormous eruption of Olympus Mons is what might have killed the planet, or at least its atmosphere. That comes from Kevin. I'm very impressed by Olympus Mons because it is the biggest volcano in the solar system, and it's staggeringly huge. But could an Olympus Mons eruption have stripped the atmosphere of Mars?
Probably not. The eruptions of Olympus Mons would certainly have sent a lot of gas into the atmosphere. Olympus Mons has probably taken a long, long time to grow. It will have had eruptions kind of like some of the bigger volcanoes on Earth. And they took a long, long time. So it's not like one big explosion. And that's why Olympus Mons is so high. It's because it's over a hot spot in Mars's mantle that just keeps on pushing out material, or did for a long period of time. And without the plate tectonics that carry the surface crust over the hot spot and results in a chain of volcanoes like we see in Hawaii, it all built this one big volcano. So it's a process that took a long time, and maybe it did play a role in the changes in Mars's atmosphere. But we think the main reason why Mars lost its atmosphere is because it is a world that is too small to sustain plate tectonics. It doesn't have a magnetic field, so the subatomic particles from the sun bombard the atmosphere continuously, and we think that's one of the main reasons why it eventually lost its atmosphere. I mean, it's not lost altogether. It's still got 0.6% of the Earth's atmospheric pressure at the surface. That's enough for winds to blow, and to sort of blow dust clouds onto solar panels of spacecraft and things of that sort. But it's certainly not an atmosphere that we would recognize as being similar to Earth's. So I think it's a good question, actually. I think Olympus Mons and the neighboring volcanoes, there's more than one big volcano there. Olympus Mons is the biggest. They probably would have affected the atmosphere of Mars, but they're probably not the root cause why the atmosphere drifted into space.
Yeah, it's more likely it was because Mars just couldn't hold itself together. Basically, it didn't have the gravity. It doesn't have the gravity to keep it hot enough to sustain plate tectonics or a magnetic dynamo, basically, which gives it a magnetic field. Yeah, but Olympus Mons is fascinating for a few reasons. Correct me if I'm wrong, but I think right now, as Mars is, Olympus Mons summit actually peaks out of the atmosphere. Is that right? It's sticking up that high?
It's certainly, I mean, the atmosphere is like Earth's atmosphere. It gradually disappears as you go higher. But yeah, I mean, effectively, the summit is the pressure will be considerably lower there than it is down at what you might call the surface of Mars.
This is one honking big shield volcano, though, isn't it? Like 21.287 kilometers in height, 13.2 miles, or 69,840 feet. Someone's going to climb that one day and stick a flag in it. It's 2.5 times the elevation of Mount Everest. And this is something about Mars that astounds me. It's a smaller planet, but all its features geographically just make ours look like tiddlywinks. And its span is 600 kilometers, 600 kilometers wide.
Yep.
That's extra. I just can't imagine it. I'd love to be able to stand there and have a look in my last 5 seconds of life because I didn't take my breathing apparatus. But it is an amazing world.
It's got cliffs as well around its base, which are pretty spectacular. I think they're kilometres high as well. So, it's quite an extraordinary world.
Yeah. Well, the caldera itself is 50 miles across. And you compare that to Kilauea, which is like a couple of miles across. It's amazing. No, I love that question. And good thinking, but probably not. And it sort of brings back the same argument on Earth that people say our global warming's caused by volcanoes and cows. It's got nothing to do with, the billions of cars that we're driving around every day. But I think they've proven that's just not the case, as far as I'm aware. Thanks for your question, Kevin. Lovely to hear from you. Our final question comes from Yuki. Hi, I'm Yuki. I'm 5 years old and I live in Canberra. We listen to your podcast nearly every day. My question is, why is hydrogen the only element that isn't made in stars? Why was hydrogen the only element around just after the Big Bang and not others?
Yeah, that's a great question. And congratulations to Yuki on being able to even think of a question like that at the age of 5, because I certainly wouldn't have been able to.
No, I wouldn't either. I was still trying to fix the wheel on my Tonka toy.
Yes, that's right. I think I was at that level. And look, the bottom line is that hydrogen, it was created in the aftermath of the Big Bang. I think sort of 3 minutes after the Big Bang, the temperature had cooled enough that you could start to form atoms. And the atom that was produced was the simplest. It's one proton. It's the simplest atomic nucleus. And so that was what basically condensed out of the aftermath of the Big Bang as energy became matter. You got protons forming, and hydrogen is protons. In fact, in that same period, you also got the start of the process that does produce other elements in stars, what we call nucleosynthesis, where the nuclei of atoms, the centers of the atoms, stick together. And that process did start. So I can't remember the percentage. It's something like 20%, I think, of the aftermath of the Big Bang is helium, which is the next most complex atomic nucleus, and formed by hydrogen atoms coming together. But then the temperature dropped far enough that you didn't get the extension of that process into the formation of other atoms. So it basically had to wait until stars started to form because of the gravitational pull of these clouds of hydrogen together, that raised the temperature again enough to start forming other elements. And so that's basically what it's all about. It's just the simplest of atoms is the hydrogen atom. That is why that was created. And we nearly got more elements being created in the Big Bang, but only helium. Actually, there's a bit of lithium and other stuff as well, tiny amounts of other nuclei. But it's true to say that the star formation and the interiors of stars is what led to the huge array of elements that we see now, all the elements of the periodic table.
Yeah,
thanks, Yuki. That's a fantastic question.
It is. When you look at the list of the top 10 gases in the universe by order of concentration, hydrogen is far and away the most dominant, with 74 to 75% of what they describe as baryonic mass. Mm-hmm. Helium at 24 to 25%, which leaves almost no room for anything else. Oxygen is less than 1%, carbon less than 0.5%, neon less than 0.1%. And then it just dwindles away. At number 10, you've got sulfur at 0.044% concentration. They're staggering numbers when you really go down the list.
The bottom line is that the Big Bang hydrogen is still around. In fact, it makes up quite a large percentage of the atoms in your body as well.
Yeah. Well, it's everywhere, isn't it? And that's the bottom line. And the way the Big Bang happened and everything that went on afterwards, if one smidgy little thing didn't happen, we probably wouldn't be here.
Yeah, that's right.
It's a scary thought, but then again, there's so much we don't know.
That's why people believe in multiverses, because they say, the conditions are exactly right for life to form in our universe, and they might not have been. Yeah. So maybe there are lots of other universes where life didn't form.
Well, yeah, the mathematics supports the theory, doesn't it?
Yeah. That's right. Yeah.
Oh gosh, the brain hurting part of the show just happened. So anyway, it just keeps us thinking, and it keeps us looking for answers, and that's what it's all about. Yuki, great to hear from you, and hope all is well in Canberra. And a reminder, if you would like to send us questions, we welcome them with open arms. You can send them through our website, spacenuts.io, and just click on the Ask Me Anything link at the top. It says AMA, and we will do our best. Don't forget to tell us who you are and where you're from, and we will put your question on if we haven't had it before. And even if we have, we might revisit them. We do that from time to time. Keep them coming. And if you haven't asked a question before and you've always wanted to, please send it in. We'd love to hear from you. And we're just about done. Fred, thank you very much.
Great pleasure, Andrew. Always good. And hopefully we'll chat again soon.
I hope so. That'd be good. Professor Fred Watson, astronomer at large, and thanks to Hugh in the studio, who didn't have a hydrogen problem, but he did have a methane problem, but he'll be out of emergency surgery very, very soon, hopefully for next week's episode. And from me, Andrew Dunkley, thanks for your company. Catch you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.